My name is Clinton, the Tech Pro, and today I'm going to be talking about binary search tree implementation in Java. So while I explain it here in this black screen, then I'm going to write the Java code here using Eclipse, and then I'm going to explain it line by line. So one thing about binary search tree is that it might be a bit confusing if you can visualize it and then you think of how Java actually implements it. So have something like 2, and to the left we have something lower than 2, and to the right we have something greater than 2, and so on and so forth. So this is actually a binary tree. So binary search tree is when this tree structure has to be searched. We need to search this tree for a key, right? So we have other subtrees here. We can have some subtree here. Okay. So now the way it is implemented in Java or in other programming languages is by means of a data structure. It could be an array. So let's say we have an array. So the idea is to split the array into two parts. So if we have a number of elements in this array, we want to split it into two parts, and as such, let me take another, sorry. And as such, we want to keep notes of the right index, the left index, and want to take note of the right. And here we have the mid. So at each point in time, once we want to search this tree, and we are trying to say we are using a recursive algorithm, we are going to split it into two, and then we are going to search. We now have this subtree, which represents actually this one, and we are going to search this left subtree. Once the key we are looking for is less than 2, we are going to search the left subtree. If it's greater than 2, then we are going to search this right subtree. So basically, at each point in time, we are going to have one other tree. So this left will be here. So once we are searching on this side of the tree, it means that right is going to move actually to this place, and we have right. If we don't find it here, we are going to move to this side, and we have left is going to move to this place. So we have left here. That is, so let's implement it. Let's start implementing it using arrays. Of course, you know that this is array. We are going to represent the first part of the array with left, the rightmost part with right, and the midpoint is left plus right over 2. So let me start a Java file. So I'm going to save file, new. I'm going to choose class, and I'm going to call it a name. I'm going to call it a name BST. Let's just call it BST. That's the name of the class. And then the source folder I want to put it, I think it should be inside SRC. Okay. So the package I would like to use should be coding. Okay. Alright. So at this point, I've created a class BST. So I want to write a function that actually will be used to implement this binary search tree. So this function is going to take an array. It's going to take the search key, and we'll need a variable to hold the right element, the rightmost index, and the leftmost index. So let's try the function public static boolean because it's a binary search tree. So we are searching this tree for a key. If it finds it, it's going to return true. If not, return false. So let's call it BST. Let's just call it BST. So we need an array to hold the tree structure. So let's use an array of integers. Array of integers. Okay. AR. Let's just say int AR. So we have int X. This is the key we are looking for. Then we need a variable to hold the leftmost element. Let's call it left. Then to hold the rightmost element. All right. Okay. So at this point, okay. So let's correct this. Okay. All right. So okay. So now this error means it's asking of a return value. We are going to fix it in a minute. So the first thing we want to check is to check if left is greater than right, meaning that actually it means either one element is in the array or zero element. In that case, we have left is greater than right. So if left is greater than right, meaning that these lefts here have actually moved, because remember we are doing partitioning. So if we continue to partition this tree until we have one single element or we have no element, in that case left becomes greater than right or equal to right. But let's use greater than. So if left is greater than right, then it means that the element is not found at this point. So return false. Okay, so why do we have this error? Okay, so I have left. All right. So if left is greater than right, return false. Else, the first thing we want to do is to find the midpoint of this array, right? So the midpoint is left plus right over 2. So let's say int mid equal to left plus right divided by 2. So this is the midpoint. Okay, so at this point we've divided this array into 2 parts. So we need to now check if this element in the midpoint is the key we are looking for. So let's say if array mid. So if the midpoint, what's happening here? If AR mid is the key we are looking for, then we are going to simply return true, because we found it. But if the midpoint is not the array, we can now either search the left or the right. So else, if the key is less than the element in the midpoint, we are now going to, in that case, we are going to search the left subtree, right? So if the key is less than the element in the midpoint, it means that it is in the left subtree. So simply say return. This time we are going to call this function this time in the left subtree. We are going to call this BST in the left subtree, giving it the array and the key, but this time the right is going to shift to mid -1. So let me just illustrate it before I continue. So there is the original array. So we have left and we have right. So we've partitioned it. Okay. So, and we found the midpoint. Let's say this is a midpoint. So we compare the key x. If the key is equal to this element in the midpoint, and if it is not, we check if it is less. And if it is less, it means that the right is now going to the left. If it's less than the element in the midpoint, then it means that the mid is now going to be mid -1. So we are now going to have mid -1 here. So mid minus right becomes mid -1, meaning that this right becomes this element. So we are only searching now from left to this place, right? So instead of using right, we are going to use mid -1. That is what is going to represent the right item. So let's go back to our code. So else return BST, and this time we have AR, the same array. We are searching. We are the same array, and this time we still have int. We have x and left. for this time, instead of using right, we are now going to use mid minus 1. Mid minus 1. Okay. All right. So that is one thing we can do. So let's see and make sure everything is okay. So I'm going to else at this time it is not in the left. It means that x is greater than the midpoint, and in this case we are now going to shift our left. Left will now be mid plus 1. So instead of using left in making the recursive call, we are going to use mid plus 1. We are going to say, let's get back to, so else, I'm now going to say return bst arx. This time we are going to say mid plus 1, mid plus 1, and then right. Okay. Okay. What error do we have? Okay, no semicolon. Right. So this is how to implement binary search tree. So let's quickly write a main program to test this, to test what we have. So I'm going to say public static void main. I'm going to say string args. Okay, so now let's create an array. Ints ar is equal to, so let's initialize as a 396 56, whatever it is. So we're just trying to do a test. So okay, so we have, okay, perfect, everything is okay. So now I'm going to say x is equal to what? Let's say we are searching for 6. So 6, x is equal to 6. Or I can simply say bst arr, the array we have, and we have searching from 0 to so from 0 to the length of the array. So we have arr.length minus 1. So we have searching for 6, and then arr, so starting from 0. So if you don't understand what happened here, so we are saying that we are calling bst on this array, and we are searching for 6, and we are starting from position 0 to the end of the list, to the end of the array. So I can just go ahead to print it out by saying, so let's say, let's just say system.out.print, and this time I'm going to print bst with everything. Alright, so at this point we have the binary search tree have been created. So now we are searching for element 6. So I'm going to just run it and let's see how it goes. So I'm going to say run as Java application. Let's look at the console. So it says true. As you can see, it says true. So let's search for 7. I'm going to run. So boom, it says false. So everything worked perfectly. So I'm going to stop here. The next class, I'm going to now discuss how to implement binary search tree using an iterative algorithm, because now we just use a recursive algorithm. Remember to subscribe to my channel if you've not done so.